All right, we are ready for part 2. I know physics is difficult, but just take a deep breath and really try to take it slow. Try to understand at each step what is going on. And please ask questions. All right, so a potential energy means the higher up it is. Well, glass on a shelf is high up. But it says here a bird flying against the wind. Now it says a ball rolling downhill, but it doesn't say how big the hill is. So I'm going to go with the bird. They fly pretty high. Okay, kinetic energy, that's which one is moving the fastest. And so I'm going to choose the one that's the car. Because the ball on top of the hill, well, it doesn't say that it's moving. And none of the others say that they're moving. So we're going to go with the fastest one. Okay, water behind a dam. So you've probably seen these rivers or lakes that they dam up. They put a huge wall to keep the water in, and then they can let it go through these little doors, and they can usually create electricity with that. So before the water is released, when it's stored, it has to be potential. Stored and potential, very similar. Okay, once it's released through the gate, now it's going to be moving, and it's moving pretty fast, so that's got to be kinetic. Okay, just before it's being released through the dam's gate, okay, sometimes we have little tricky questions on here, so you just got to think. It's before it's released. It's still potential energy. It has not been moving. Fossil fuels, gasoline, oil, coal, kerosene, all of those have chemical energy because it's stored in the actual molecules of that substance. Okay, energy to produce electricity. If it's a windmill, that means it's got moving parts. And if it's got moving parts, it's going to be mechanical. Okay, a candle, when you light the candle, you understand that it's giving off light and heat. But what did it come from? It came from the chemical energy stored in the wax molecules. So when the wax molecules are burnt, it gives off that energy. Okay, now we have a pendulum. Okay, so our pendulum, position 1, it is 6 joules and 0. Now that means it's got a total of 6 joules. Okay, I'm going to skip number 2 for now. Let's go to number 3. So 3, potential energy is 0. I know that because it's the very bottom of the swing. It is as lowest as it can go, and so that has to be 0. So if the total has to be 6 from our first one, I know that kinetic energy has to be 6. At 4, it's going to be the same thing because 1 and 4 go up to the same height. Okay, so it has 6 potential energy, 6 joules potential energy, and it's at that moment that it actually stops. So it goes up, stops for a moment, and comes back. You probably remember the pendulum lab. So potential is 0. I'm sorry. Potential is 6. Kinetic is 0 because it's at the point where it stopped. Now this one, to me, it looks like this is about a third of the way. So it'd be like 1/3, 2/3, 3/3. So I can see that this is a third. I know that this whole part right here has to be 6 joules of energy. So I'm going to take a third of 6 joules. So 6 divided by 3. So there'd be 2, 2, and 2. So it has decreased by 2. That means that the potential is 4 because 6 take away the 2 that it lost. And then the 2 joules, because it looks to me like a third of the way, so a third of 6. And the total has to equal 0. Okay, I know I'm giving you a lot of roller coasters, but I want to give you a lot of practice. The test is not going to have this many problems on it. I just want you to practice and learn this well. Okay, so here I've got this little roller coaster. And this little roller coaster, it starts up here. Okay, so I need to figure out what is the gravitational potential energy or potential energy, the kinetic, and the ME mechanical. Well, if it's sitting up here, it's not moving. Okay, that means that kinetic has to be 0. Okay, that says 20. How'd they get that? Well, if you take the formula, you take the mass, it says right here, 0.5 kilograms. So 0.5 times 10, because again, I'm going to round this because these are multiple choice problems, and I really don't have to show my work. And if you don't want to round, that's fine. So I'm going to take 5 times G, which I'm rounding to 10, and times 4, because that's 4 meters. And that gives me 20. Okay, so 20 minus 10. No, sorry. I can't read my own writing. So 20 plus 0. So I'm adding these together to get 20. Okay, now we're going to look at step 2. Okay, so step 2, I have got 3 meters. So I'm going to do the same problem, and I'm going to take 0.5, which is the mass, which is given to me, times 10, which is 9.81 rounded, times the 3 meters, and I get 15 joules. So I know that's potential energy. If 20 is the ME, if these have to be the same, then what do I get? My missing number, I get 5. Okay, let's take the last two. So for number 3, I can see it's all the way at the bottom, so this has to be 0. Okay, how did they get the 20? I'm showing you how to get the gravitational potential. If that's 0, and you know that the total is 20, you just subtract. The last part, it's a meter high, and so I'm going to calculate this number. I'm going to take MGH, so I'm going to take the mass times the 9.81 rounded times 1 meter. That gives me 5 joules. I know that has to be here. 20 is the total, so 5 minus 20, or vice versa, 20 minus 5 gives me 15. That was my missing number here. Okay, this next question, I just want you to do a little self-reflection. What do you think you should do? So kind of make a plan on how you're going to pass this test. Okay, and here you should know, for example, if you're talking about food that people eat, or gasoline, or striking a match, you're talking about chemical bonds, chemical energy. Thermal energy melts ice cream and it heats soup. So just understand, if I give you different situations, can you name the type of energy? Okay, so energy conversion. So if I give you a picture, can you figure out what the changes is? So for example, here I have a battery. Okay, this battery is going to be put in this flashlight, and it's going to go from chemical energy to electricity, and the electricity is going to produce light. I'm going to put chemical energy as gasoline into the car. It's going to start moving, have kinetic energy, and also the engine gets hot, which is thermal energy. Electric energy gets changed into thermal because you put the bread in a toaster, the elements get hot, and it toasts the bread. Chemical energy in an apple, kid eats it, he starts riding his bike, and that's kinetic energy. And of course there's a lot of other types. There's a lot of other types of energy, but these are the main ones. So electric energy turns into light. Solar energy gets stored into the cells of the plant. Plant grows, and it's storing chemical energy. Okay, here are some definitions for you. Okay, so what I'd like you to know is be able to tell me what these are. So the period goes from side to side. So the time it takes to go here and turn around and come back, that is the period. And we use a T for it. The amplitude is the distance from here to here. So the distance from the middle to the outside of the swing, the farthest away it goes, that's your amplitude. The length, well, all that is the distance from here all the way down to the bottom of the ball. That would be L, the length of your string plus the bob. Okay, the frequency is you count 1 second and you count how many times it goes back and forth in 1 second. And the bob, this is the bob right there. Okay, here's the bob at just different positions. Okay, so let's see, we are at the end. Yes, I hope this helps you, and I hope that you do really well on the test. Have confidence in yourself, take things easy, and I wish you much luck.